start now. I'm going to start a whole 2 seconds early. Good morning, everybody. For those of you who are here on time, you notice a lot of people are maybe stuck in rush hour traffic or something. Did you happen to look at a bottle of vinegar and think acetic acid, carboxylic acid? Or did you happen to smell the flowers and think of esters? Or did you happen to, I don't know, pick up a box of fabric softener or bottle and say, look, that has a quaternary ammonium salt? Organic chemistry is everywhere, and you're learning about it. All right. What I'm going through today will not be on the test tomorrow. Remember, tomorrow, test number 3, start promptly at the top of the hour. And we're talking about, I don't know how I say we, I was talking about fats and oils, and they're all triglycerides and triester. Ester number 1, ester number 2, ester number 3. And I showed you how you can hydrolyze it to make an alcohol and a carboxylic acid from these. I showed you, I guess it was a couple of days ago, last Thursday, acid and base hydrolysis, and let's just go through one of them. Each one of these is an ester. Take an ester, and I hope you know this for tomorrow, react it with acid and water. You'll get back the alcohol you would have used to make that, plus the carboxylic acid you would have used to make that. Therefore, for the 3 esters, first ester, you'll get this alcohol plus this carboxylic acid. And this is stuff I went through on Thursday, but I'd like to review it. This middle ester, you get this alcohol. Remember, and especially tomorrow, you break carbon-carbon single bonds, and you get this alcohol plus this carboxylic acid. And finally, the last ester, you'll get this alcohol, which is still connected to that carbon, which you now have glycerin, and you get the 3rd carboxylic acid from your triester, your fat oil, your triglyceride. Now, if you look at this, what you're making is glycerin and these carboxylic acids. Well, since they're from fats and oils, they should be called fatty carboxylic acids, but chemists, organic chemists are lazy. And fatty carboxylic acid, that's a lot to say. Oh, let's just call these fatty acids. And they are. Let's talk about fatty acids. Again, switches on for test number 4 today, not tomorrow's test. And fatty acids are naturally occurring carboxylic acids with unbranched. That means they're always always CH2, 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 minus CH3, straight chain. And it turns out Mother Nature likes even numbers. If you add this carbon plus the number of carbons in either R prime, or R double prime, it's always an even number. And it turns out that number for fats and oils with the carbonyl carbon, your R prime or R double prime, is somewhere between 12 and 26 carbons. Ooh, I have to warn you, math alert. Remember I said in my class, the first part of the semester, You have to know how to add and subtract up to 4 and count up to 10. Math alert, you have to now know how to count up to 20. And these are fatty acids. And this is an industry I worked in heavily. I worked for a company that made fatty acids and glycerin from fats and oil, mainly fats. Now, there are a couple of different types of fats, fatty acids. And the first type I'd like to talk about is saturated fatty acids. Oh, I heard that before. Remember a long time ago, we had saturated hydrocarbons? That meant a hydrocarbon was only carbon single bonds. Well, a saturated fatty acid is oh, I apologize. Having worked in this, I didn't even notice it. I went and did some slang. FA is short for fatty acids. When you're working in it, you never write down fatty acids, put down FA, but that should be fatty acid. It's a fatty acid with carbon chain, which all the carbon-carbon bonds in are single bonds. And what is wrong in the definition, and you should know the definition of what a saturated fatty acid is. If you say a saturated fatty acid is a molecule of all carbon-carbon, all single bonds, notice there's a double bond. So make sure you identify this carbon-carbon single bond. Now, there are many different ones. I would like you to know the structure and the common name for just one. And I haven't used it all semester, but now I'm using it. This means when you have something in parentheses, it's repeated however many times. In this case, 16, so it'd be CH3, CH2, 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 16 times. And then carboxylic acid formula. And this is a saturated fatty acid. How do I know it's saturated? Because they're only carbon-carbon single bonds and the R group carbon-carbon single bond. And this is called stearic acid. And stearic acid is an acid that's made a lot for many things that you use in your daily life. If you look at a high-quality candle, 50% of the weight of that candle is stearic acid. It's high quality. Low quality is less and more paraffin wax. So that's a candle. In fact, the company I work for that made fatty acids got its start back in the late 1700s in a town in the Netherlands that took animal fat, made stearic acid from it by a similar reaction, and made candles. By the way, how many of you have ever heard of the cheese spelled Gouda? And how do you pronounce it? Gouda. No, that's the American way. The company was headquartered in that town, which I visited and spent a lot of time there. And it's pronounced Gouda. That's the Dutch way of saying that town. And they still had a candle maker, which I have a collection of hand-dipped candles that are about this big and beautiful. And also, they had a couple of really nice cheese stores. In fact, I would stay in The Hague, which is really pronounced in Haag, and I'd take a train to Gouda, which is the smallest town. I'd get off and I'd have about a 10-minute walk from the railroad station to where I was working. And I'd go there and I'd be in that town or working there for 2 weeks at a time. And I'd be in Europe and I'd be in England for another week, in Germany for a week. I usually spend a month in Europe. And it was a beautiful walk because I walked down the canals. They had a couple of windmills still there, which is beautiful. And I passed the cheese warehouse and the city hall that was already quite old before Columbus set sail. So it's a very nice way to start your day. All right, this is stearic acid. It's found in candles. There's another product that you're familiar with that contains about half the weight stearic acid, and it's made by a company that used to be called, and still is a division called Vinnie Smith. Anybody ever hear of Vinnie Smith? They're now owned by Hallmark, who might have sold it to someone else. Nobody knows Benny Smith? They make Crayola crayon. And when I worked for a company, Unichem Chemical, we were the sole supplier of stearic acid. As a Crayola crayon, 50% of the weight is stearic acid. And one time I got a call from our president, said, "You're going to be on the plane tomorrow morning to Pennsylvania, out of Scranton or somewhere else." Our salesman will pick you up. "You got to go to Benny Smith. What's wrong?" "They're having a problem. Go sell them." That was part of my job. And so the next day I was there, and I went to their headquarters in Pennsylvania. I forgot which town, near Scranton or some Philadelphia, somewhere in that area. And you walk in, they have this huge atrium, sort of like the building here. And on the walls and hanging were the winners of different contests from K through 12 that they have in the United States for artwork with their Crayola crayons. And some of them were just astounding. And the problem was they had 4 new colors. They made them, and after 2 weeks in the box, the pigment which makes the Crayola crayon that color, because paraffin wax and stearic acid are white, migrated just from the tip. So if a little kid gets a new box of crayons, looks at the new color, he's excited, and looks at the tip and sees white, what is he going to do? Tell his mom, "Look, this is broken." And I had to help him fix it, and I got to see how they made Crayola crayons, which is amazing too. So you should know that if on the test, if I write this structure, what's this common name, you should know stearic acid. If I ask you to draw stearic acid, you should be able to draw that. By the way, the IUPAC name, which I won't ask you to learn, is octadecanoic acid, oct 18, 8 plus dec 10, octadeca, and OACE acid, carboxylic acid. Now, interesting thing you know about esters. How do you name an ester from this molecule? Drop the IC, the word acid, and add OATE. If you look at any of your personal care items, skin, hair, shampoos, or conditioners and all that, you see the name stearate in there. That's an ester made from stearic acid, which means it was made from animal fat, which there's nothing wrong with that, but most of the things in your conditioners, a lot of them come originally from either vegetable oil or animal fats. All right, let's move on. Now, you can also have another type of fatty acid. Remember, one of the fatty acids from, and I'll show you later, comes from this hydrolysis and stearic acid. Now, another fatty acid I'd like to talk about is oleic acid. And oleic acid is monounsaturated fatty acid. Well, mono means one, unsaturated. Oh, I remember the first, when we got into hydrocarbons, I talked about unsaturated hydrocarbons, and those are compounds that have a carbon-carbon double or triple bond. Well, it turns out Mother Nature never made, and still never has made, triple bonds. She doesn't like them. She doesn't talk to me though. But anyways, I know she's never made them, but we're talking about carbon-carbon double bonds. Mono, one, unsaturated double bond fatty acid. And a monounsaturated fatty acid is a fatty acid that has a carbon chain with at least one, or only one, carbon-carbon double bond present. You should know how to describe that. And I'd just like you to look at one structure. And this is a structure of oleic acid, which is the common name. For this compound, which would be 9-octadecaenoic acid for the IUPAC name, but nobody calls it. They call it oleic acid. And oleic acid has a double bond starting always at C9. It can be cis or trans. Remember, double bonds with the hydrogens on the same side is called cis. When they're on opposite sides of a plane coming out from the double bond, or your hand, or your arm or pencil, that's trans. And in oleic acid, the double bond can be cis or trans. And you should know, if on a test, I write down the structure, what's its common name, you should know it's oleic acid. If on a test I put down, draw the structure of oleic acid, you should use this. Now it turns out oleic acid is a liquid at room temperature, which makes it good for certain things. And similar to stearic acid, you can make esters from oleic acid, like you can do with any carboxylic acid, and those would be called, drop the IC at the word acid at OATE, oleate. And if you look at your personal care products, hair conditioners or other things, skin creams, and certain cosmetics, and you see the word or the ingredient that part of the name has oleate, which they are in there, you'll know it comes from an ester of oleic acid, which came from usually fat or oil. Now, I won't ask this on a test, but you can also have polyunsaturated fatty acids. And poly means many, unsaturated carbon-carbon double bond. And here you can have the R group in a fatty acid having more than one double bond, which means two or more. And the key ones there are linoleic and linolenic, two double bonds and three double bonds, which I will not ask on the test. Now, if you look at the double bond in either oleic acid or other unsaturated fatty acids, what does that really mean? If you have a fatty acid that can have a cis or trans bond in it, that means if R prime had a double bond, that double bond can be cis or trans, which makes the fat cis or trans. How many of you have heard that trans fats are bad for you? I think some of you. If you've been following for the last 5 or 6 or even longer, medical science has found, I'm not a medical doctor, so I don't know what was the evidence, but I believe what they've been publishing, talking about, and so do big corporations, because you can go into many places in the supermarket or big companies like McDonald's, and they switched over to zero trans fats. And what that means is the R group, when this is hydrolyzed, that makes the fatty acid like oleic acid, that R group, they're all cis, not trans. How that affects your health, I have no idea, but it does. And what that means is, the next time you're in the supermarket, walking down one of the most dangerous places in the supermarket for me, the potato chip aisle, and you pick up a bag of, say, Lay's potato chips, the sour cream and onion, the best, most dangerous, and you look in the upper corner and it says zero trans fats, you can turn to your friend, neighbor, or loved one and say, you know that means the R group in the triglyceride has only cis double bonds? No, I don't do that. People don't like hearing organic chemistry in supermarkets. Trust me. All right, having worked in this area, let me teach you a few things. And part of this, the switch is off, part of it is on. Remember, we're talking about fats and oils. A fat is a solid or semi-solid triglyceride at room temperature, and oil is a liquid triglyceride at room temperature. Well, in industry, we have different names for what you know as fats and oils. Some are the same, some are different. Beef fat is not called beef fat. This is something you should know. I'll write on the board. Beef fat is called tallow. And that's just, I don't know how it got that name. And remember I had for quaternary ammonia salts R sub T, where I said it's a tallow alkyl group. That means it's made from beef fat. So I hate to break the news, but guess what? Your fabric softener is made usually from animal fat. It's cheaper than vegetable oil. Now, the next thing, which I have on there, is pig's fat. Now, you know it probably as lard, but in the chemical industry, and this is something I'll write here you should know, it's called two different types. White grease. No, I didn't invent it. That was lame. And yellow grease. And white grease is usually a slightly less color, which means it's costs a little more. The more color something is, the more you got to do to clean it up if you're making a colorless product. And yellow grease is slightly yellow. And it's always, not always, but most of the time it's cheaper than tallow, but because in the United States, at least for a long time, more people eat beef than pork products, there's usually more tallow available on the market. Now, a couple of things. If you know where to look, which I do, you can find what's the weekly price of a grade of tallow, which I have on the slide there, BFT, which stands for Bleachable Fancy Tallow, in two places I would look. One is a magazine, which my local library actually has. It's called CMR, Chemical Marketing Report. And weekly they have the prices, FOB, Chicago, New York, and other places, meaning if you bought it right there in the city. Cities for BFT, tallow. Another place that's there weekly, if you know where to look, is the Wall Street Journal. Bet you didn't think about it, but this is a very important raw material. Many things you use in your daily life are based on these animal fats. And therefore, contracts written for products that are based on these are based on a multiplier on the weekly price of either BFT or white grease or yellow grease. That's reported, like I said, weekly. Usually a contract will actually say, based on the weekly price of the either Chemical Marketing Reporter or the Wall Street Journal. But you didn't think chemistry was in the Wall Street Journal on a weekly basis. I should tell you the company I worked for, which I was one of the jobs, I was in charge of quality control, so we had to check all the tallow and white grease and yellow grease we bought that was coming in, that it was what we wanted, and the same right purity. We would buy per week anywhere between 2 to 3 million pounds of these fats. Usually it was mostly tallow unless we could get white grease or yellow grease, because these are always cheaper than tallow. And if you're buying, say, 150 million pounds a year or something, you can save a few pennies, like 3 or 4. That's a lot of money. All right, now a couple other things is coconut oil, you know about soybean oil, that's an oil, corn oil, olive oil. And then there's this one, I don't know, has anybody here heard of rapeseed oil? If you go to developing countries or poor countries throughout the world, instead of using things like corn oil, soybean oil for cooking, or vegetable oil, which is a mixture of corn oil and other things, or olive oil, you use rapeseed oil because it comes from a rapeseed plant, which you can grow just about anywhere, especially in Canada. They grow a lot of it. And it's cheap. And it tastes similar to vegetable oil, but it's got this stigma. It's for people who don't have money in developing countries. Well, a number of years ago, Canadians in this one group who was trying to sell their rapeseed oil, especially to Americans who weren't buying it, because am I going to buy rapeseed oil? Oh, that's a funny name, and I don't want it. Well, how can we convince them to do that? And what they did was someone came up with a good idea, let's change the name. Well, what should we call it? Well, it comes from Canada, and it's an oil, vegetable oil. And let's call it canola oil. And if you go into your local supermarket now, I'm sure you'll be able to find where they have the cooking oils, you'll find canola oil, and you don't think anything negative about it, but it's really rapeseed oil. Everybody bring their binoculars. All right, I'm turning the switch off for this chart. There's only two things I've asked you to learn, but there's some key fatty acids, which means the R group in the triglyceride contain these. Lauric, these are common names, 12 carbons, myristic, 14, palmitic, 16, stearic, 18. The last one I've never worked with, so I don't even know how to pronounce that properly, so I'm not going to blow it. And that's 20. Now, I have worked with oleic. You should know stearic and oleic. It has 18. Now, here in the book, they say cis, but it's also trans. And linoleic and linolenic with 2 and 3 double bonds, and they can be cis or trans. They have 18 carbons. And notice saturated, solid at room temperature, unsaturated, and it's liquid at room temperature. I have palmitic acid on the board, or on the screen. Let's look at something interesting. In World War II, there was this very deadly weapon developed for the American Armed Forces, mainly the, I don't think they called it the Air Force back then, but for the different air forces of the Navy, Marines, Army, to drop on the enemy. And it was a weapon that, there was this gel that was in a canister underneath a plane. They drop it, it burst open, spread this liquid, catch fire, and the liquid was such it would stick to your skin. What do I mean by stick to your skin? Well, if you ever take your finger and put it in a jar of mayonnaise and pull it out, the mayonnaise will be stuck to your skin. This does the same. And I worked for a company, I met some of the old timers who helped develop that weapon. And it turns out the original formulation for that weapon, which was used through Vietnam, also Vietnam War, which was changed somewhat, and this changed. I don't know if it's still in their arsenal or not, but the original formulation was a mixture of water and gasoline. And if you ever seen in a gas station, after a rainstorm, you know the light reflecting off the top like a little rainbow? That's the gasoline that was on the asphalt on top of the water puddles. Water and gasoline don't mix. Well, how can you get it to mix to make a gel? You need what's called a surfactant, and I'll teach you about that later on in this chapter. But the surfactant that the company I worked for, these old timers, created was they took palmitic acid, R's of P, 16 carbons, reacted with sodium hydroxide, you know this reaction, acid-base, and made this soap or surfactant. And the name of it, common name, would be sodium, common name palmitic acid. Drop the IC into word acid, add ATE, palmitate, sodium palmitate. And from that, one of the people who I met, they were thinking, what do we call this new weapon? And he said, well, look, this is sodium. That's an important chemical that we use to make it, and it comes from palmitic acid. They call it napalm. True story. Organic chemistry has been used for many things. All right, switch is still off, but let's take a look at the real world. And if we look at fatty acids, there's two types, saturated and unsaturated. If you listen to your doctor, which I do, and he's warned me about it, and I've changed my diet, that if you have a high level of saturated fats in your diet, that's bad for you. And my doctor was quite brutal. He said, you know, you keep on eating with your triglyceride level with all the saturated triglycerides, you're in the 10% level of, you'll be dead in 5 years. You're in that bad level. So I got the message. Well, if we look at what is saturated, remember only carbon-carbon single bonds, in the R group unsaturated double bonds there. And if we look at butter, it's highly unsaturated, or saturated, I'm sorry, which is why it's not good for you. Lard is about 50-50. Tallow, and whoever wrote this chart, this is an oxymoron. You can't mix tallow. If you put down tallow, you don't need the word beef if you work in the industry. And it's about roughly, it's not exactly 42, 58, but roughly 50-50 mixture saturated. Human fat, actually higher, 56, almost 60%. Now, what does medical science say are good fats for you? Olive oil, and notice it's highly unsaturated, almost 90%, at 90%. Palm oil, corn oil, peanut oil, these are all better for you, even though, as my doctor says, even the better ones take in moderation. And since I don't want to be underground, I like it being alive, I listen to them. All right, let's get back to reactions, which is on. Now, I showed you two reactions where if you take a triglyceride, react with water and acid, you break it down to an alcohol, or glycerin, an alcohol, triol actually, and fatty acids, carboxylic acid. I also showed you can do that with base, and you get the carboxylate anions, water and base. Now, what are those two catalysts? What does a catalyst do? It lowers the activation energy so a reaction goes quicker. Key reason you use a catalyst, you want it done quicker. And in industry, you learn time is money. The quicker you can do something, the more money you can make, which is a good thing. So, how else can you make a reaction go quicker? Let's see, well, I already said that. Well, it's on this thumb. There's a rule of thumb, which is, I hope you learned in general chemistry, when for every 10 degrees C increase in the reaction temperature, the reaction rate doubles. So for most reactions, not all, but most, if you heat up the reaction, it goes quicker. Well, how can you cheaply heat up this reaction with water? Use steam. And what's steam? Very hot water. And if you have high pressure steam, you can be very hot, so lethal if you get it on you. And what this does is the same thing as if it were acid catalyzed. Let's look at an ester first. Now let me remind you, steam is just hot water. And in this case, you don't need the acid catalyst because the heat does the catalyzing, but it's the same products as acid catalyzed, except this is cheaper. And therefore, if we look at this triglyceride, a fat or oil, top ester, what do I get? The alcohol. This, what would be, oops. Dreaded oxygen virus got my oxygen there. Anyway, you'll get this alcohol plus this carboxylic acid. Second ester, you'll get this, and you're getting the hang of it, it's going to be glycerin, and you'll get this carboxylic acid or fatty acid. And the final ester right here have one. And the company I worked for, which was located by the old White Sox Park, was at 47th Racine, they're still there. They had, well, we had these columns which we actually injected steam at one end, the fat, liquid fat at the other, and it interacted, and we could separate it in the middle. And we called them splitters because we, in the industry, you're splitting the ester, even though it's a hydrolysis. And we ran 5 of those every hour of the day, every day of the year, around the clock. And that's why we needed 2 to 3 million pounds of fat, because we were making these. What the company made was these fatty acids, which we further separated, and we sold stearic and oleic acid, which were big sellers. In fact, that's how I got to know people at Neutrogena, because they buy high quality oleic and stearic acid for a number of their products. And if you've ever heard of Neutrogena, they usually in the industry buy some of the highest quality raw materials, which means their products are high quality, which is also why they charge you a lot of money for that quality. Now I'd like to do something, it's somewhat artificial, but it gives you a feel for the real world. If we look at a fat or oil, like tallow or yellow grease, let's just stick to the fats that I know quite well, how would you represent that? And this is my artificial representation that gives you a good job. If you remember the slide I just had before showing tallow, it was roughly a 50-50 mixture of saturated and unsaturated fatty acids, which comes from the hydrolysis of that fat. And if you looked at yellow grease and white grease, it's about the same. And it turns out we could use those interchangeably in our production. So what I'm going to do is, when you have R sub S, that means this carbon plus what's in R, there's 18 total carbons, and it's saturated. S stands for stearic. And you can also have abbreviated R sub O. This is oleic acid. That means the carbonyl carbon plus R sub O, 18 carbons, at C9 and R sub O is a double bond. And therefore, how would I show these in here? Well, there's about a 50-50 mixture. Uh-oh. Oh my God, how do you do 50-50 of 3 things? We can't split this in half. So what I do is this. And this is my little pun, SOS. Anybody know what that means? Save our ship, Morse code. But anyways, this is going to be my designation for tallow, white grease, yellow grease. And now I can do chemistry with this. And if I take this, and this is what we did where I work, if you take this and I have on there reacted with strong base and water saponification, and everybody got this written down? Going once, twice? Keeping with my promise, no new reactions, general reactions. If we look at each ester in the triglyceride, top one will give me the alcohol. and then I'll get the sodium salt. And that's called sodium stearate. Center alcohol. I'll get this, or ester, I'll get this alcohol, but now instead of R sub S, it's R sub O, instead of using prime and double prime. And you get sodium oleate. And the final one, and remember on my test, what do I say? Give the organic product or product. I don't ask you to balance it. You get this alcohol. And this would give you another molecule of sodium stearate. If you want to put a 2 there, you don't. You can, but I wouldn't. And because I'm lazy, I'm an organic chemist. And when you do a base saponification, or saponification of a fat or oil, like beef fat, you'll get glycerin, sodium stearate, sodium oleate. And next week, I'll have a nice show and tell, but if you look at the back of a bar soap, at the label, it will say either sodium tallowate, which is a mixture of these two, which is called tallow fatty acids, and that's why they call it tallowate, or you'll see sodium stearate and sodium oleate. And they separate the glycerin. Your ancestors, my ancestors, how did they make soap originally? Or for a long, long time, they took animal fat, beef fat mainly, boiled it up in water and lye. What is lye? Sodium hydroxide. And the white solid in there, they separated and they made it into bars, and we call it bar soap. So next time you wash your hands with a bar of soap, warning, I'm going to ruin something for you. The material that made that soap came from a cow or a pig. Like I said, organic chemistry is everywhere, even in your bathroom or wherever else. Seems like a long time ago, not that long. I taught you if you have a double bond and you add hydrogen in a catalyst, you break the pi bond, and each atom of the carbon atom gets a hydrogen, and it's called hydrogenation of a double bond. If I were to do the following reaction, what would I get? Was anybody here know a reaction of a carboxylic acid with hydrogen and a catalyst? Because I don't. Do you know a reaction of a double bond with hydrogen and a catalyst? You do. So what's the product here? You'll break the pi bond, and each carbon will get a hydrogen. Do you break carbon-carbon in single bonds? No. So I can write this like this, or I can rewrite it, CH3, 7, remember, you have now to count up to 20 now, or higher numbers, plus 2 is 9, plus 7 more is 16, CH2s, which I can rewrite this way, either way on a test would be correct. And my carboxylic acid. And what am I really showing you? If you take oleic acid and hydrogenate it, what do you get? Stearic acid. And remember, R sub O means oleic acid. Why don't you try the reaction on the top? What would be the product or products of the following?
I just had a question about the bar soap.
About what?
The bar soap.
What about it?
What about people who don't want to use animal products?
I haven't been in that industry for a while. Well, actually, when I was in that industry, we just made it and sold to people who bought this stuff.
Okay.
It probably, I don't know, I'm guessing now, and I'll be honest, I'm guessing. Let me get out of Danielle's way so she can see it, and now I'm blocking everybody else's. But anyways, I would research on the internet, and that's the nice thing about having a good search engine in the internet, vegetable-based soaps. And I'm sure somebody has, I don't have time now, but somebody has made that, because if you want it, there are other people, and there probably is a niche like that. The other thing that would also fill that kind of niche is if you wanted kosher soap, or what's the name, and I always pronounce it wrong, for Muslim being, their dietary laws, someone help me out. What? Allah? What? Halal. I pronounce it wrong. And if you want a product not made from, and a lot of the animal fat is usually pig fat because it's cheaper than tallow. It's usually, but there's more tallow on the market, at least years when I was in the business. I still consult, but I'm not on a daily basis talking to purchasing agent when we buy the stuff, which I would consult. He'd consult me, is it's good quality or not? When we buy it, it's good price. No, you can't, it's garbage. And things like that. Yes, you can, it's good. So that would be my advice here. But first, vegetable-based soap.
Because I
And
have a lot of
vegetable oil.
hippie friends who
What?
I have a lot of hippie friends who absolutely refuse to use any animal products at all, and they would like.
I respect
lose their
that.
mind and maybe
For a long
there's
time, my
some-
younger sister was a vegetarian, and she wasn't a vegetarian. She went back to eating things like eggs and fish, but not
Oh,
meat,
the
red meat. No.
lacto-vegetarian.
I respect all that. All right, let's get back to this, but that's a good question. The nice thing is, you now have the education and the knowledge to search those things and look into them. All right, question is, what's the product of this reaction? What is this, oleic acid, hydrogenated? What are you really doing? Getting rid of that double bond? What do you make? Stearic acid? And that would be the answer. You could have written this too. This also doing, I'm saying this part is R sub O. This part is R sub S. So what does that take us to? Hydrogenated fats and oils. How many of you have heard of hydrogenated fats and oils or partially hydrogenated? And medical science says they're not good for you, hydrogenated fats and oils. Well, why did they make them? This industry can make money. And let me show you something real quick, which now you have the knowledge for. Am I out of time? No, then settle down, we need an extra 50 seconds. What happens to hydrogenated fats and oils? You get rid of double bond. Here, this is R sub O becomes, as you see over there, R sub S. Now, in real life, what's expensive? Butter. What can I do? if I take vegetable oil, which really in vegetable oil, most of these are RSO, I can do this and make them RSO sterile groups, which means it's going to be a solid or semi-solid room temperature. I can put some yellow food coloring in, some flavoring, some water, mix it together, put it in the tub and call it margarine, and charge you a lot of money and make a lot of money and not care about unruly your heart. And that's why hydrogenated fats and oils are bad for you. And I apologize, when a whole 10 seconds over. Don't forget, test tomorrow, please be on time.